Hi again. So now I want to show you the inference options on Stapplet, and we're going to skip simulation for this class. You can play around with it if you want. Remember, that's just another way to get the sample-to-sample variation or standard error by doing a simulation. So it's really fun, but just don't have enough time to do it all in this class. So we are going to look at the theoretical. There's four theoretical forms of inference. We're going to do a t-interval and a t-test. Those are what we just did by hand-ish. We still use some of the output for the standard error. And then we're going to look at two new things, which we're only going to use technology for, but I'll explain what they are. A prediction interval for the value of a response variable, and a confidence interval for the mean of the response variable. So I'll explain what those are. But let's look at the first two first, okay? So, and let's go on to Stapplet and go ahead and do this. So hopefully you still have your data entered in there. If not, just enter it in again. It's really good practice. And then go all the way down to simulate sample core, go all the way down to perform inference. We're not doing simulation, as I just said. And we're going to look at, we can do t-test or t-interval. What do I have? I have the t-test first, since that's what we did. We did the t-test first on the last page in the last video. So I'm going to select that the alternative is beta greater, boy, I can't talk today. Beta less than 0, perform inference, and this is what we got, right? We got very close to this, like 3.99 something. Oh, I know I have that page nearby. Yeah, we got negative 3.9907, so very close, and we got a more precise p-value, okay? So just pay attention to whether it says to show your steps or whether you can use a theoretical calculator. You can always check this way as well. And then let's look at our t-interval. And we did a 90% confidence level. And let's see, now this is the one before we adjusted, before we multiplied by 1,000. So it's negative 0.0612 to negative 0.0249. Ours ended up being rounded to 0.25, so that is equivalent. So that is the same, essentially the same right there, okay? Okay, so let me show you that on the notes. So on the notes, we did a t-test for slope. We got to put in our alternate and perform inference, and that's what we got. But we can get more precise on our t distribution. But our test statistic matches what we got. And then same idea with the next one, the t-interval for slope, and we did 90%, and here we got our lower bound and upper bound. So we have our confidence interval, confidence interval for the slope is all below 0. And we rejected the null, so that's why those two matched up. Okay, great. And then I just have printed out here on the notes that other box, the more detailed, oops, I got a typo there. We need an E in there. More detailed regression. It's way too many consonants in a row. Way too many, more detailed regression output, okay? So we have our constant. This is the y-intercept. Let's just put some notes. Y-intercept, and then this is, and it took me a while to figure this out in the last video, this is the x variable, but it's the slope of the y with regard to that variable. So if you ever take a class on multiple linear regression, you could see multiple different variables here, maybe x1, x2, x3, and they would each have a coefficient in front of them. So that's why the x variable is used, and of course it's in relation to the y. So this is the slope of that variable. And so pattern I didn't really talk about yet, but this is what we did in our formula, right? We took this divided by that, because it was b minus 0 divided by the standard error, and that equals, I don't know how to draw my arrows here, but that equals the t statistic, right? Okay, so that's the y-intercept, and this is the slope. Related to that x variable. All right, so we're just using the slope row in this class. Okay, great. So we've got one more page, and I'm going to continue and show you the prediction intervals. So let me get that page real quick. And I suppose you have to get that page too. Okay, let me explain what these are. Okay, and we're only going to use technology for this, so don't worry about doing these calculations yourself, okay? You can play around if you want to figure out how it's doing it, you can, but it gets a little bit technical. Which of course you could do, would just beyond the scope of this class. Okay, so a prediction interval for an individual value of a response variable given an explanatory value. Okay, what does this mean? So let's look at an example for why we would want to do this. A student named Cam is planning to attend Elmhurst University, okay? And they want to estimate about how much financial aid they're likely to receive based on their family's income of $52,000, okay? So using this model, they want to make a prediction, and that's a big reason for making this type of model, is to put in an x and find a y, right? Find the best estimate for the predicted value using the linear model, okay? Okay, so actually this one we are going to do by hand, but it's the other one that I was thinking about, so sorry, I misspoke there. Find the best estimate for the predicted value using the linear model. Okay, so the model we got is the formula we got, right? And I do have it, it's the best page. Okay, my pages are all over the place. Here's our equation, right? So let's write this out. I'm just going to do, I'm going to cut this down to cents and do 4 right there. So y hat is 24,319.33 minus 0.0431, and then x is our variable, right? But that's the value we're going to put in. So let me do that next. Y hat is 24,319.33 minus 0.0431. Now I'm going to put in the 52,000. Okay, and really important here, we want to double check the format of the x values. Let me write that down first. Check the format. Okay, what do I mean by that? Well, this income was 52,000, but maybe in the data set it's in thousands, and so it's only entered as 52, right? This one, remember, was in dollars. Let's go back and double check. Family income is in dollars, okay? So I want to make sure that it's entered as 52000, right? Which looks like it is. If this said thousands of dollars, then I would just need to put in 52. Otherwise, I would get way too big or small of a value, right? Value wouldn't make sense. So just be mindful. Same thing with percent. Like if one of these, if your x is a percentage, is it is 10% written as 10 or 0.10, right? You want to make sure you match the way the X values are entered, okay? So I could even write that. It's an even better way to say it. Match the way the X values are entered or formatted. Okay, so I double check that. It is 52,000. Now we can go ahead and calculate this, and then we'll check it on Stapplet. 24,319.33. And remember, if your slope's negative, be sure you get that minus in there. 0.0431 times 52,000. Okay, so I'm getting 22,078 and 13 cents. Okay. Put the dollars on there. 22,000 78 and 13 cents. Now we could call this a point estimate, right? This is an estimate. It's a predicted value, right? Okay, so this is a prediction, okay? Now the part we're going to use Stapplet for is the prediction interval. So we want to get an interval around this because this is just a point estimate. But again, this is all average and there's variation, so we want to get a range for this, okay? So if a question says just to find the predicted value for an individual, you can do it by hand. And then into Stapplet, we're going to go to a prediction interval, okay? So we'll use Stapplet to find the prediction interval, and then we want to use a certain confidence level as well. Okay, so back here, here's where we did the interval, we did the t-test, t-interval. Now we're doing prediction interval for a value. And this is where we have to type in the actual value. So this is 52,000. And here I'm doing confidence. I noticed in the notes I did confidence level of 95%. I'm not entirely sure if that should be the 90 like we did for the confidence interval. So I'm just going to keep it for now to match the notes. And it'll tell you that in the question. I have to think a little bit more about if maybe that should have been 90 instead. But so here we get a lower bound and an upper bound. But let's say we just want to predict this with 95% confidence. Then that's a little bit different than our hypothesis test. So here's our prediction interval. So let's write that out. I think I've got it on the notes, just double checking it's the same. So let's write out what this means, okay? Here's our lower bound. To upper bound, you notice the 48 degrees of freedom. Okay, so with 95% confidence, we can predict that Cam or Cam's family can expect to be offered between these two values, and they're positive, so they go from lower to higher. So 12,307, and I could also just make that 308.78. It's an estimate, so going out to the cents isn't necessarily that useful, but I already wrote it. And 31,851. Okay. So notice this is pretty wide, and our point estimate was, of course, right in the middle. It should be, because it's a plus and minus situation, right? So that should be exactly in the middle. But this gives us a sense of the variation. Maybe there's multiple students whose family income is $52,000, and they would be all over the place within this interval, right? So it is pretty wide for an individual, and that's because there's more individual to individual variation than sample to sample variation, okay? So this is going to be generally pretty wide, okay? So, take it for what it's worth and how useful it is, but it gives you some idea. Let's say you're CAM and you want to know, well, it gives you some idea. Like 8,000 is less likely, and 40 or 50,000 is also way less likely, right? So let's just make a note that this is really wide for an individual. Because there is lots of individual to individual. I know it's a lot to write that word out a lot. Individual to individual variation. Okay. Okay, great. So let's check out the next thing we're going to do. The wording is similar, but the difference is it's a confidence interval for a mean, the mean of a response variable, given an explanatory value, just like we were given the 52,000. So let's see what the difference in the interpretation is here. Suppose the CAM would like to estimate the mean financial aid award for all prospective Elmhurst students whose families earn $52,000 a year. Okay, so now we're talking a mean, estimating a mean versus an individual. Okay, so Stapplet will calculate a confidence interval for that as well. Okay, so let's go over and do that. I've got the inputs here on this screen. So just be really conscious of whether it asks you for prediction interval for a value or confidence interval for a mean. Okay, very different. In this case, they're the same explanatory value of 52,000. And let's continue with the 95%. This is pretty cool. We'll play with that in a second. So now we're getting 20,341 to 23,817. Okay, notice how that's a lot tighter, and that's because we're estimating an average versus for an individual. So let's write that out. Here's the what we got right here. So this is the same value, same input value. And also the same point estimate, right? So we would have the same 22,000 we got by plugging in the x value. Same point estimate, but the standard error is smaller for the mean. Okay. It's more reliable to predict a mean than an individual value, and it has to do with sample to sample variation is a lot smaller than individual to individual variation. So it's more reliable to predict a mean than an individual value. So that's why it's much narrower. This one is much narrower. So let's write out the interpretation for this one. And I could say CAM's family, or CAM or we can be 95% confident that the average aid award offered to families who make 52,000 is between, I've got our two numbers here. This time I'm just going to cut it off with the dollars, but I'm going to round. 20,342 and 23,817. Okay, so you see the difference there between those two, predicting for an individual and then predicting for a mean with the same input value, or we could have different input values for a different type of question. Okay, let's go back real quick. I'm curious, I don't think I've played around with this before. It says show interval bounds on the scatter plot with regression line. So if I check that, I'm curious what's going to happen. Ah, really cool, huh? So see how this is the, these are the bounds. I don't quite know how to explain this yet, so I might have to do that in class or in a different video. Let me just see if that they also had that option on the other one. Yeah, they did. Show interval bounds on the scatter plot with the regression line. So what do you think this one's going to be? Much wider, right? Oh, okay, I get it. So it just took me a minute. Because it's a different, I was confused about why it was varying, but because each x value, you're plugging in an x value, gives a different prediction interval. That's why they're a little bit different. And you'll notice that they get a little wider on the ends than in the middle, because it's closer to the average in the middle. Let me go back to the other one. Prediction confidence interval. And let's go back to the top. So much narrower because it's a mean, and also much narrower in the middle because that is also closer to the mean. So a little more variation on the ends. Okay. Okay, great. Well, depending on how the class is organized, this might be our last video. If it is, thank you for watching. It's been fantastic. Okay, bye-bye.